and HP surface inclination will be given with respect to HP. That will be drawn in the second position of the projection. In the first position, we have to keep it parallel to the plane as per the change of position method. Once it is first position is drawn, the second position we will keep the surface of the lamina parallel inclined to the HP or whatever is given in the data, either HP or VP. In this problem, it is inclined to HP, so surface will be inclined to HP. In the third position, we have to keep the edge on which it rests is inclined to VP. So surface is inclined to HP, edge is inclined to VP. This is the situation. Let us go through the question here. An equilateral triangular lamina of side 25 mm lies on one of its sides on HP. One of its sides, one of its edges should be on the HP. The lamina makes 45 degree with HP. Lamina makes 45 degree with HP means surface of the lamina makes 45 degree with HP and its median is inclined at 40 degree to VP. Median is inclined at 40 degree to VP. What is median? Median is a line drawn from the corner of the each triangle to the center of the opposite edge. So CD1 is one of the median. Similarly, we can draw one more median from the B to center of the AC, another median from the corner A to center of BC. Like this, we can uh, draw the medians. So maximum three medians can be written. One of its medians is inclined at 40 degree to VP. So, so for the HP, surface is inclined. For VP, median is inclined. In the previous problem, edge was inclined to VP. Here, median is inclined to VP. This median inclined to VP makes a big change. Because of that, we have to find out the beta angle, one more angle in the third position. That we'll understand why and how. So, first we have to draw the surface is inclined to HP. So, first we will keep the surface parallel to HP so that on HP we will get the true shape of the triangle. True shape of the triangle is 25 mm equilateral triangle. We are getting this here. When we project it, we will get the straight line BC and within the bracket A dash because A is exactly behind B. When you look at from this side, you can see only B line BC, but we cannot see point A which is behind B. So we here in the front view we see only a line which is B dash, A dash, and C dash. Now the second question is surface inclined to HP. Surface inclined to HP means this B dash A dash line. This line should be inclined to HP means it appears on VP. So on VP, tilt this line B dash C dash by an angle 45 degrees. This is the surface inclination to HP. Then you project it down, you will get one more triangle. This one. This is the apparent shape of the triangle. Apparent shape of the triangle. Here what happens? Length AB in the first figure and length AP in the second figure remains in this remaining the same because it is parallel to HP. Whereas AC and BC is changing its length in the second triangle. So it is the apparent shape of the triangle. Now, next question is next our task is to keep the median CD inclined at an angle of 40 degree to at an angle 40 degree to VP. Inclined to 40 degree to VP. Inclined 40 degree to VP means it appears on HP. HP means below the XY line. So we have to draw a line at an angle of 40 degree. On that 40 degree, we have to measure the original length of the median, that is CD1. CD1. This point is C, and with the compass cut an arc here, radius is equal to CD1. And draw an horizontal line passing through this because this has locus of D. Locus of D. Then come to the second figure. This is the apparent length of the median. So 40 degree is the true angle given in the data. Infinite 40 degree to VP is the true angle. So with that we have to take the true length of the meridian. That's why we took the CD1 as the radius here in the first time. Then we got the locus of D1, locus of D. Then measure the apparent length from the second triangle. This is CD with the compass. Then keep the one end of the compass on C. Cut an arc on the locus line here. It cuts here. Then join D to C, D to C, and draw a line and extend it up to XY. Then measure this angle. This angle counts to be 71 degree. So we have to find one more angle here in this case. This is called beta angle problem. Why we have to find a beta angle? Because the edge which is inclined to VP is changing its length from the first figure to the second figure. In the first figure it is CD1, whereas in the second figure it is CD. Length is changing. When the length is changing, we should find out one more angle. If the length remains the same, we don't need to find out one more angle because apparent length should incline with the apparent angle. True length should incline with the true inclination. That's the condition. Okay. Now we'll go to the problem. Go to the Solidity software. Do the sheet setup. Go to background. Set a 4 size sheet. Remove the background. So details. Okay. Then put the screen. Go to the line command. Select 0.13 continuous line. Draw one horizontal line here. Then go to text command. Text let us set this as 1.5 and this is X, this is Y, this is VP, this is HP. Then you have to draw a triangle of 25 mm. Go to line command, take 0.5 mm thickness, draw a 25 mm line, 0 degree, then 25 mm, 120 degree, enter, then join this. This is a equilateral triangle of 25 mm. Now, resting on one of its edge. So, what you have to do is, when the condition given is resting on one of its edge, we have to tilt the triangle in such a way that one of its edge comes to the your left side. Comes to your left side. So, this is the point of rotation. This is the center of rotation. This is the point to rotate from. Rotate it like this, so that this edge comes to your left side because it is resting on one of its edge. Then name it. So AB is the edge on which it is resting. You can write here AB is the edge on which angle is resting on HP. This is a condition given. Okay. So because it is resting on edge AB should come to your left side. This is one of the important facts you should note. Then do the dimensioning. Go to smart dimension. Do it, the dimensioning. The top view is over. Top view, keeping the surface parallel to HP. We have done the top view. This is called change of position method. In the data, you are not given, you are not asked us to keep the surface parallel, but this is the method you have to follow. First position, we should keep it parallel to the HP and get the true shape. Then only we can complete the apparent shape of the triangle. Front view will be a line, and then name it. The front view we are drawing looking from this side. So when you look from here, we see only BC. We cannot see point A. So point A is exactly behind B. So what we do is we name it as B dash within the bracket A dash, and this is C dash. Okay. Then second position is this is surface parallel to B. This is a change of position method. We are keeping it parallel to HP. Second position will be surface inclined to HP. Surface inclined to HP. How much angle given? Go to the data. Angle given is 45 degrees. Surface inclined to HP at 45 degrees. So what we'll do? Select this line. Select this line. And then move then rotate click on the center of the read here, click for the center of rotation. So this end should be the center of rotation, this end should be the point of rotation. It should be rotated by an angle of 45 degree, and position angle is also 45 degree. Come out and right click, then go to line command, thin line, draw a vertical from let us zoom it, it's very small, let us zoom it. Yes, draw a vertical from C, vertical from D, A, horizontal from A, it cuts the vertical from A at this point. Similarly, horizontal from B, it cuts here. Horizontal from C, it cuts here. Then trim the extra lines. Don't keep any extra lines. Then name it. This point is A. This point is B. This is C. Then join ABC by a dark line, 0.5 thickness. So you got the apparent shape of the triangle in the second position. This is inclined to surface inclined to HP at an angle of 45 degree. Now, third position is median inclined to HP. Median inclined to VP 40 degree. Third position. Okay. So now what we'll do? So come here. So what is median? Median is a line joining the corner to the center of the opposite edge. This is the one. So let us call this as D1. Let us call this as D. CD1 is the original length of the median, and this is the C to D is the apparent length of the median. So original length is 21.65. This is comes to be 15.31. So length of the median is changing from 21.65 to 15.31. when the length of the median is changing or length of the reference edge is changing, in the third question here, we have to find out beta angle. So this is the one important thing we should remember. Most of the students will be under confusion when to find out the beta angle. When the edge of reference is changing its length in the third question, we should go for the one more angle that's called beta angle. Okay, now we'll go to that. There is some mistake here. Let me check this. Delete this. Delete this. Draw line correctly. It will not position properly. So from this end point to this end point, and this end point to this end point. Okay. Now draw another line at an angle 40 degree to VP. So below the axle line should come, angle should be minus 40 degree, and length, draw some free length. Draw some free length, and this should be thin line 0.13. Now 21.65 the original length of the median. Take a arc by center point. Take any point here. Draw a radius of 21.65. 21.65 mm. Sweep angle is 0. Okay. And then go to line command. Select a chain line 0.13 because we want to draw a. Before that, let us trim this. Go to line command, chain line and 0.13 because chain line is equal to draw the locus line. This is the locus. This is the locus line. Okay. Then let us name it. This is CD1. This is D1. C is some area. Let us how to identifying C is difficult. What we'll do from here, draw one line, continuous line from the end point of this. Draw one continuous line. Length is 21.65. Okay. Here 21.65. It here. There's a mistake. Go to line command. From this point, draw one 21.65. 21.65. Enter. What is the 34? This is wrong. We should take 21.65. Somehow we have taken 34. So what I do is I'll delete everything. I'll do it again. Okay. I delete this. Delete this. Delete this. Delete this. What we do is take a curve, continuous line 0.20. Take any point here and draw a line of 21.65, radius of 21.65, and line arc. Trim this here. Draw a line from here to 21.6 by 21.6 here, an angle and put it enter. Okay. Go to line command, chain line. We have to draw a locus line here, so chain line. Then name it. This is C. This is D1. Let us keep that D1 little closer to here. Move this and keep it here. Okay. Now we have to find out CD. CD length is 15.31. So again go to arc by center point. Move the cursor here. We'll get the endpoint symbol here. Yeah, got endpoint symbol, right? Click there. Then draw an arc of radius 15.31. 15.31. Yes. Draw an arc like this. It is cutting the locus line at a point. What is this? Locus of D. Let me name it. Locus of D. Then trim this. Then from here. Draw a line from here. Join this line. Then go to extend the next command. Select this line. This should be a continuous line. Measure the angle. This angle, this is the angle. Draw the angle from here to here, 65 degree. Okay, so 65 degree the beta angle we have found a new angle. 40 degree was given in the data. Now we got CD line. This is D. Now on this CD, we have to keep the second rectangle. This one. We have to keep move this rectangle now. Select it. By triangle. By center triangle and move. Copy on. Move from the point C. Fit here. Get the endpoint symbol. Keep it when the endpoint symbol appears. Then come out, right click. Again go to rotate command. Rotate. This is the center rotation. This is the point rotate from. Rotate it up to here. So we got CABD. Okay, now you got it. What we did is we just moved the second triangle onto the 65 degree line such that CD is on the 65 degree line. That's important. Median should be on the 65 degree line. So CD is on the 65 degree line. That's important. Now we turn it. Now we have to find out the front view. To find out the front view, again projection we have to do horizontal from C, vertical from C, A, this is B, trim the unwanted line. Extra lines, whatever we have to trim that. So name it. This is C dash. Here, this is A dash. This is B dash. Then exit, go to line command. Select the 0.5 mm thickness. Draw a line from A dash to B dash, B dash to C dash, C dash to back to A dash. So this is the solution for the problem. So here we have found out the beta angle. So in this point, from this problem, you should understand when we have to find out beta angle. When the edge of reference, which is inclined to VP, changes its position from the first figure to the second figure, we have to find out the beta angle. Okay, with this, now we'll end the class meeting. Bye.